There we go. I can see you, everyone. I can see everyone. Hello, everyone. Thanks for joining. So I'm Sydney, and I'm joined with Jeff, my colleague. And yeah, so I'm part of the core architecture team at Atlassian. Jeff's one of our cloud platform architects. So at Atlassian, we've been all in on sort of cloud native microservices for quite some time. We started probably about 8 years ago, and now we have over 1,000 12-factor app style services running in production. So, we use a lot of Docker, we use configs code, or, deploy in AWS, all that kind of jazz. So the promise of microservices for us was team autonomy, right? That really gelled with the Atlassian culture, right? It's where, you don't tell engineers what to do, you provide them with context, and you trust that they'll do the right thing. And as architects, we've found that an interesting challenge sort of helping teams as they build this ever-evolving mass of services and pushing it in a direction to help us deliver value to our customers in a quick format or a quick way. So today we want to share some of the lessons we've learned and some of the patterns we've used as architects. Just a bit of logistics. Please feel free to ask questions in the chat. We'll try to keep an eye on it, and we'll try to get to it at the end in the Q&A or shortly after. All right, so let's start at the beginning. So do you know the feeling when you know something's not quite right? You don't know exactly what it is. You don't want to cause panic, but you want to dig into it a little bit more. Now, that's kind of how I felt. Obviously not as cool as Neo or Morpheus. This is probably what I'm like. But why did I feel this way? Well, I've been on this microservice bandwagon for quite some time. I joined Atlassian to build microservices. I really like that teams are empowered to work independently, towards that shared goal. I used to be part of the Scala minority, and so having a safe space where I could build using the tech stack and the language and the style that I liked, and as long as I delivered, that was really, really comforting. And I thought the idea of microservices would be that, as we build more services, we actually get more productive, right? Because we're able to compose services now, so you should be able to write less code to deliver more functionality. But then after a while, I sort of realized, this wasn't really quite happening that way. And I thought, yes, at the beginning, we're going to build our infrastructure, we're going to learn how to build and run services. But even after a while, we weren't kind of getting that scale out that I was expecting from a microservice architecture. So I did some soul searching, and I came to a realization. Microservices give teams false autonomy. All right, so this is a big statement here, and I think there's four reasons for this. So firstly, dependencies were a big thing in the monolith world. Right, teams had to get their code and deployments all coordinated because the monolith had to go out all at once. All right, but hey, microservices, we're decoupled. We just talk through APIs. All right, that's pretty easy. And yes, we can have a mess like the distributed ball of mud, so to speak. But if we package up our components, so they're standalone, we can avoid that, right? We don't have to do that. Well, the challenge is even with these sort of separate components, we have to combine them together into these end-to-end functions that we're building. All right, our products are filled with hundreds of these functions, so there are tens or hundreds of services composed together. End-to-end workflows in the traditional IT environment, same story. Things have to fit together end-to-end. And when you have a few of these components, that's pretty easy to line up. But as you add more and more of these components, there's more chance for these APIs to be misaligned purely because there's just more moving parts. All right. And you add to that, you start reusing these components. All right. That gets even harder. And what's worse is even if you want to change an API, just to make that alignment happen, it actually gets harder, ironically, as we reuse our code more. All right. We're actually moving slower to make changes. So the second reason, well, actually before I move on, so even beyond API schemas, we actually need to think about operational concerns. So does that service blowing up there? Do we you don't want an end-to-end flow or end-to-end function failing because we forgot or we didn't realize one of these services was at a lower reliability tier than we expected. Alrighty. So another type of dependency we have is actually on domain experts, on people. So if you think about an end-to-end flow that team A is building, all right, it's relying on a service from team B, and we may have to make some change to that service. But that service is, that team B is, pretty smashed. All right, they're busy. So what can we do? Well, there's three options. So firstly, the idea of microservices is, hey, you could unblock yourself, build it yourself. All right, and that's fine for many services, but sometimes services have require a lot of specialized knowledge, deep domain knowledge. So for example, user logins. It's actually quite hard because they've got to scale. It's got security concerns, it's got crypto. You've got to understand protocols like SAML and OAuth that aren't so easy to grok. So as a team, would you go and invest your time and effort learning all these intricacies when it's not really a core focus for your team or your team's mission? Well, probably not. So instead, maybe you could inner source, right, or contribute to Team B's code, all right? But you think about it from Team B's perspective, are they going to trust someone else coming into their code base to make changes, especially if it requires deep domain knowledge, all right? Because remember, any mistakes that happen, well, Team B's the one who's going to get called, right? They're going to get paged because they're the ones who own that service. Right? So that's not, really encourage the microservices environment. So what choice do we have? Well, we wait, right? We put it on the Team B's backlog, and eventually it will get built. All right, so we have to live with that scheduling dependency, which isn't great. All right, so the third reason for this false autonomy is dealing with cross-cutting concerns. So I think many of us have felt the joys of the General Data Protection Regulation, GDPR, over the last few years. It's been jokingly called by some the general destroyer of product roadmaps. And the reason for that is it has wide range of concerns, right? It impacts all systems, all people, all across a company. And in a monolith, hey, these changes could be relatively easily put in place, right? You can find replace code, in a single repository, in a single monolith. But our distributed network of microservices wasn't really designed for these kind of changes, right? You want teams to work independently, right? These kind of changes are hard by their nature. And you can argue that, hey, these cross-cutting concerns don't come that often. But what we've found is that actually happens more often than you realize. And the reason is, our customers, our end users, regulators, they see our software as monoliths, all right? They want consistent experiences across all the UIs, APIs. They don't care that there's a microservices architecture under the covers and teams work independently. You don't want personal data that should be deleted across a company accidentally being retained in one service because, hey, that service was a separate service that we forgot about. And the final reason for this false autonomy is the cost of keeping the lights on, or KTLO. All right. As a team, you own your services. That's great, but you're not working on the things you always want to work on all the time. All right. You need to maintain your builds, update your base libraries and base images. Take care of vulnerabilities. You've got to be on call. You've got to do preemptive maintenance, monitoring, all that kind of stuff. All right. Back in the monolith world, you could have an ops team kind of take care of that for you. But now you're on your own services. You got to clean up after yourself. Just like moving out of home. Yes, you get freedom, but your mom's not there to wash up after you. So, we've talked about a number of reasons why sort of microservices give false autonomy and things, as architects, I was thinking, well, hey, we kind of let this loose on our engineers or on our engineers in our companies. Is there something we can do as architects to improve the situation? And I started thinking, well, in the monolith world, we didn't have these challenges. We had different challenges, but these particular ones, weren't there. So maybe we can learn some lessons from how we used to do things and apply it to the microservices world. So let's talk about what we used to do as monolithic architects. So firstly, monolith architects were the end-to-end solution people, right? They understood the ins and outs of their monolith. They knew where all the nooks and crannies were, all the landmines were, and so forth. I remember when I was going to make changes to the Jira monolith, I'd go to the Jira architect first, all right? Not because they were the ivory tower people who demanded respect and needed to approve everything. No, it's because they knew all the landmines were. They knew what all the other teams were working on. So that actually saved me time because they could tell me up front what to watch out for. So this I guess call the inward-facing job of an architect. Architects also had an outward-facing job, right? So monoliths had to integrate with other monolithic systems, all right? And having all the full context of how their system worked made them the perfect people to sort of negotiate end-to-end functionality across a company, right? Think end-to-end API contracts in simplistic terms. Now, with all this context, both inside and outside of their teams and their services or their monoliths, architects were the people, or the go-to people for managers to come to them to help resolve dependencies. Right? They could plan out and work out what components they need to build, when they need to build it, just to get monoliths out the door. And finally, again, with all this extra context, they're the ones who can drive sort of patterns that we see in our code. They can define things like how teams should do transactions and validation, how they handle personal data for GDPR reasons. Right? Patterns were how architects shared the context to enforce cross-cutting concerns amongst all the teams that are working on the monolith. So in a sense, architects were the trusted advisors. All right? Engineers turned to them for guidance to understand how they fit into the bigger picture. Managers turned to them basically as the dependency resolution experts, right? So in a monolith world, it had a big role, right? But in a microservices world where teams own their own services, like how does that play out, right? Like you can't have a single person knowing the entire set of services across a company, right? I used to be in identity and when as an architect in identity, and we had maybe 40 services at the time. There was no way I understood what each and every one of those 40 services did. And even if I did, it changed on a week-by-week basis because teams were autonomous. All right. So we need to kind of recreate the singular architect view amongst all the various little engineers across all the teams. So how do we do this? Jeff, you want to talk us through some principles?
Perfect. Thanks, Sidney. So like Sidney said, we're in this microservices world now. And we want to maintain this trusted advisor role. But based on what Sidney's saying, it's clear we need to go about things a little bit differently. So what do I mean? I mean, when we're thinking about building software, right, we're typically first thinking about technology, right? That's what first comes to mind. So we're making those decisions like, do we use Java or do we use Kotlin, right? Do we use microservices or should we just start with a monolith? How do we scale our database? These kind of questions. And there's no doubt that we need to tackle these questions, but we have to recognize that invariably it's actually people who need to work through these questions, and it's the same people that need to bring our software to life. So as architects in this microservices world, we need to be able to influence people to make software successful in today's world, right? And what most of us have learned, whether it's in personal relationships or work relationships or whatever it may be, successful relationships, they're built on trust. So the question for us as architects, if we want to build successful software, is how do we build trust? So I want to actually take a quick step back. I actually had a major in economics, and I want to offer up a quick economics lesson. So I want to talk about a win-win game. So what's a win-win game? It's where two parties actually come together and they work out ahead by making a deal. So working through an example, if you weren't aware, Canada exports a ton of lumber, no pun intended, right? Canada exports lumber as one of its primary exports. And so they've invested in machinery and they have expertise in producing lumber, right? Of course. And Mexico has basically done the same thing, but they've done that for produce, right? Fruits and vegetables. So if Mexico and Canada didn't trade with each other, then basically Canada would need to figure out how to grow produce, right? Because in this example, they don't have any. And that's difficult, right? Because Canada can't grow most produce, right? Given its climate. And Mexico would also need to figure out how to produce lumber, but Mexico doesn't want to produce lumber because they have rainforests, and to be honest, they're better and they're already doing other things. So if Mexico and Canada come together and they basically produce an agreement, right, a trade agreement, and they agree that they want to trade lumber and produce, then actually Canada and Mexico are both ahead. They each get to continue to do what they're doing, but they get both goods, right? And they each get to specialize as well. So Canada continues to invest into lumber. They get better at it. They get more economies of scale and so on and so forth, right? And Mexico does the same. And so they're better by working together. And this is the concept of a win-win relationship. So we want to talk about how we turn this win-win theory into some principles that we can use in the software world, right? Because that's why we're here. So Sidney and I have been working together for 3.5 years now, right? Almost 4 years. We've worked across lots of different projects and teams. And so in preparing for this presentation, we sat down virtually on Zoom, and we identified 3 of our most important principles that we thought we were able to use to build trust across our peers and be able to influence architecture successfully. So the first one is we need to lean into up-leveling people and the process. The second one is that we want to focus on guardrails and really avoid to become guardians of our domains. And the third thing is that we need to shift our engagement left. In other words, we want to get involved earlier, right? Shift engagement earlier. So let's talk about that first one, technology, people, process. And this is such an important takeaway. We wanted to keep reiterating, this is our #1 principle. So in the past, if we have a monolithic architecture, we can actually rely on technology, that top one, a little bit more, because everyone's sharing a common code base, right? So there's a single build pipeline, there's common libraries, there's end-to-end tests, there's integration tests everywhere. And sort of we're all sharing this, right? So technology lends almost a larger hand there. The monolithic architecture, of course, has its own downsides, though, which is why we're talking microservices today. And many of the problems that Sidney was talking through are just, they're unique to microservices, right? They weren't there, or at least not to the current extent that they were in this monolithic world. So in today's world, if we want to solve some of these problems, we need to be able to influence the direction that technology moves through the people and through process within our companies. So it's this trio that we're always talking about, right? Technology, people, process. But what's different in the microservices world is that on the technology side, you're talking about platform, right? You have to expect to invest more into your platform. And we'll talk about the how and why to do that in a little bit. On the people side, teams have more autonomy, right? That's the intent of microservices. And so that domain expertise that Sidney was referring to, it gets siloed, right, as a result of this. So as an architect, we need to be the facilitators of that collaboration across people and across teams, right, from a technology perspective. And Sidney will talk a little bit more about how to do this in a little bit. And lastly, on the process side, as architects, you need to invest a bit more into patterns, right, and leverage those patterns to get teams and services, which are otherwise moving sort of autonomously. You got to get them sort of moving in somewhat of a similar direction, right? And we'll talk about some examples of how to do this. All right, so this is principle #1, and I want to talk a little bit more about how we talk about decision-making and going about this. And this is principle #2. So here we're talking about shifting from being a gatekeeper of those decisions towards implementing guardrails and allowing other people to make those decisions. So this is something that requires trust, right? It's the same trust principle. It takes time to build trust, and we have to remember that trust, personal, professional, it's a two-way street, right? So that means you need to sort of respect your peers and they need to respect you. So let's walk through an example. So you see on the left, this ivory tower architect. So an ivory tower architect would insist on being the driver or the approver of every decision that's going on. And they'd say, I need to approve this decision because I need to make sure we don't make the wrong decision, right? I want to make sure we don't make a mistake. What we really want to think about, rather than approving each individual decision, we instead want to focus on sort of the wider context, right? And setting guardrails around it rather than solving the specific problem at hand. So we can do this by talking about strategic outcomes of the project or the direction of a product, whatever we're trying to build, where we want it to go. We can form an architectural vision and kind of frame it in that context. And these are all ways to help guide the decisions, but still focusing on sort of the context rather than the decision at hand. And then for particular decisions, we want to be available as a sounding board, right? Be like that consultant for your peers, and you'll grow into that trusted advisor role. And for particular decisions, be there to spar with your peers, right? Help them iterate on ideas. And it actually gives you a nice opportunity if you need to nudge things in a particular direction, you feel it needs a little extra help. You can actually use these sparring sessions as a way to sort of convince people of your ideas or kind of subtly nudge people in a certain direction if you need to. So by following these types of principles, your peers will stop thinking of you as a gatekeeper and start to think of you as that trusted advisor, right? That sparring partner to help them work through their own decisions. All right, that's principle #2, and we're talking about how to guide those decisions. And next, we want to talk about when we want to get involved with them. So principle number 3 is called shift engagement left. And you may have heard about shift left within testing or security or something like this. But we're taking that same concept and we're applying it to software development. And the point here is to get involved earlier in the software development lifecycle. So often we think about software like ifs, whiles, for loops, right? Or zeros and ones and unit tests and things like this. But in reality, it's a bit of an emotional minefield, right? Because people are spending their time and their energy and their passion building a product. And when they do that, people begin to feel pride in their work. And this is actually a positive thing. We don't want to stop this. This is the thing that drives our technology products forward. However, it's also the thing that can sometimes turn negative, right? And so that pride that develops over time can sometimes make people a little bit reluctant to change and sometimes a bit defensive over the decisions that have actually been made. So as an architect, our job is to continuously improve products. Right? And you can see how these butt up against each other to create a bit of a sticky situation. So as a result, our principle number 3 involves getting involved earlier in the decision-making process, right? And by starting to spar with your peers a bit earlier, when they're thinking about ideas, we can avoid some of the defensiveness that comes by discussing what's already been implemented, right? Should it be merged? And instead we can redirect that energy a little bit earlier in the process on decisions that we haven't yet made, right? What are the best approaches to make? And we can make those things together. And by doing this, we avoid those defensive conversations and we can focus a bit more on the positive ones, reinforcing that trust principle. And it also gives us an opportunity to guide towards some of the approaches or patterns that we think will help the team succeed in the long term, right? So on that note, I actually want to hand it back to Sidney, and Sidney's going to introduce us to some implementation patterns that are using these principles.
All right. Alrighty, thanks, Jeff. So yes, we're architects, we love patterns, right? So let's turn these principles into 4, I guess, win-win-win patterns, win-win for everyone. So the first one is architecture guilds. And that's a way we can sort of rebuild that end-to-end view that we used to have. Then we'll talk about trade agreements as a way of building trust between teams. We'll also talk about incremental multiplier patterns and smart platformization as a way to take care of those cross-cutting concerns and also deal with KTLO and so forth. All right, so architecture guilds. All right, so I talked about not being able to have singular architects anymore, right? So is there a way we can sort of get the senior engineers from all the various teams together and sort of have them sort of share context with each other and with their teams, sort of act as one, all right? Be the face of architecture, both to the teams and for managers. Yes, we could try to do that, but you can't just say, hey, grab these bunch of people and become a guild, right? There needs to be some structure. And to talk about that, let's take a little bit of a tangent and talk a little about the roles that senior engineers play in our companies. So there are a number of models for this. Staffeng.com is a very popular one. In my mental model, I see there's 3 roles that senior engineers play. All right, so there are the deep engineers. Right, they're in the code base day in, day out. They know all their services really, really well. They're enablers for their immediate team. All right. Then there's deep architects, right? So these architects or these engineers work across a number of teams to make sure various services kind of align to form logical capabilities. They have the same sort of failover strategies and the same operational capabilities and so forth. They're not in the code base all the time, just some of the time. And finally, there are these broad architects, right? And so these are the ones who have that sort of end-to-end solution view, right? Very high level. And so they might, for example, ensure that the customer experience from signing up a website through to provisioning, through to getting access to a product, through to getting build is taken care of. So as an individual engineer, we can play either 1, 1.5, maybe 2 of these roles sustainably at one time. All right, never all 3, or you'll get burnt out. But that's a topic for another talk. What's important here is we need the right mix of these 3 roles in our architecture guilds. All right, so what is that right composition? Well, let's now talk about the idea of company-wide capability maps. All right, think of these as drawing up a company-wide architecture diagram. All right, You can start at a very high level of like broad domains that a company might have, like identity systems or infrastructure or data, so to speak. And what you can do is you can add more detail, like you zoom in, like you do a Google Maps, right? You can add more details as you zoom in. And so you can break these broad domains up into capabilities that form those domains. And then even further down to the individual services that make up those capabilities. All right. Now, if you look at a side-on view of this, you get to sort of these layers, all right, these levels. And it becomes very clear that deep engineers sort of focus their time on the services part. You have deep architects that look after various capabilities, and the broad architects kind of take care of cross-domain considerations. And the purpose of these guilds then is to break these silos down between the various teams and between the various layers or levels we've got. All right, and this kind of tells you the kind of composition of the different types of guilds within a company. Now, a couple of things to note on this page. Obviously, deep engineers and broad architects do talk. All right, it's not a pure hierarchy, right? But obviously, there are sort of engineers who work close together on a day-to-day basis, right? And that's what these guilds are about. And secondly, this might look like a lot of infrastructure, a lot of process, right? But it's actually not. Like this doesn't. You don't have to start with this from day one, right? Like I remember in last year we had a very relatively small architecture forum to begin with. And then over time, as the company grows, number of services grow, you can add more guilds horizontally as well as vertically. All right, so that's the structure of guilds. The one last thing I want to talk about is guilds and their missions, right? And this is really important, right? You want to avoid the situation where you get a bunch of engineers together and they bike shed, they talk and talk and talk and not actually deliver any value, all right? So it's important to have concrete deliverables, right? Some tangible outcomes that guilds have. It might be responsible for end-to-end solutions. It might be responsible for evaluating and spiking out new technologies and providing recommendations to teams. It might be providing, I guess, by patterns, for example, cross-cutting patterns to deliver that teams can use and so forth. Right. Having these concrete or tangible outcomes is really important because it enables buy-in from the various teams, right? Because teams can see they're getting value out of these guilds. And also it also gets buy-in from leadership because engineers' time to these guilds is not small, right? It's a lot of time, a lot of effort, right? They need to see some return on investment. Alrighty, so moving on to the next part, which is trade agreements. And so just like countries have trade agreements, we can have trade agreements between teams in companies as well, right? So in the real world, country leaders negotiate trade agreements for that win-win, like Canada and Mexico that Jeff was talking about. And once those trade agreements are in place, then the individual teams, like people or companies, can trade using those agreements, those guardrails, so to speak, right, to get to that win-win for everyone. All right. So what does that look like in the software world? Well, when we have teams that sort of interact closely in certain domains, it's valuable. Well, we found it extremely valuable to literally write down contracts in a way, or agreements, right? To concretely define what those domain boundaries are. So there's no arguments, all right? We also discussed the high-level APIs and data transfers between various domains. We also importantly talk about rules of engagement. So when do teams involve each other and how do they do that? And we might also talk about sort of general expectations on non-functionals, right? So general expectations of reliability, latencies, and other performance characteristics. So let's talk about a concrete example. So in Identity, also in Atlassian, we have our extension platform that allows third-party developers to extend our apps, right? And that's a combination of three sort of different domains in Atlassian. So there's the ecosystem, which is they take care of the user and developer experience, generally speaking. We have identity, takes care of all the auth stuff like tokens and so forth. And you have admin experiences, all right? They take care of customer admins wanting to apply policies to how users interact with their third-party apps. And so one area of confusion actually was the user consent screen, right? So the screen when you log in with Google, it asks you, do you want to share your profile with someone else, with some other system? And so this is a UX concern. So it's user experience. Is it an ecosystem thing? Or is it so coupled with OAuth and tokens and so forth? Is it an identity thing? All right, so we literally worked it out and said, no, ecosystem, you own this, but identity will provide you these sets of APIs, these callbacks and so forth to make it work seamlessly. And then between identity and admin experience, we negotiated how data transfers happen between us to enable the admin experience team to do their job. And we also captured rules of engagement. So ecosystem knew when to involve the admin experience team to bring in that customer admin persona. So these agreements enabled the individual teams within those domains to execute independently. They knew when to talk to each other. And over time, because things were moving smoothly, they kind of built up trust, right? There just weren't any arguments. So the thing with these trade agreements is they obviously have to evolve, just like in real life, right? So in the real world, allies get closer and closer together, and maybe sometimes a country sort of falls into hardship. And the allies come in and provide aid and resources and so forth. And the same happens with teams, all right? So for example, the identity and the admin experience teams work really close together on a lot of features, all right? So much so that over time, the identity team is happy for or comfortable with admin experience engineers coming in and making changes in their code base for certain features, all right? It's breaking down those silos between teams and that fear that someone else could make a mistake, causing me to be paged. And also over time, agreements need to be renegotiated, right? Orgs restructures happen, people move, services move around. Trust ebbs and flows over time, and it's really important to keep on top of that to make these trade agreements run smoothly over a long period of time. Jeff, over to you.
Thanks, Sidney. So Sidney's been talking a bit on the process and the people side of things, but it's still a technology situation, and we still need to figure out how we get autonomous teams to actually move in tandem with each other from a technological point of view. So we found that one of the best tools to do this is to identify these things we're calling multiplier patterns. And these multiplier patterns are our method for sharing technology, basically different approaches across varied microservices. And what makes them multipliers is that these are the patterns that have seen traction and would also be beneficial for other teams to adopt. So they could be in the form of libraries or even microservices, but at a minimum, we're just trying to formalize the implementation approach. What's nice is that these multiplier patterns allow other services to easily adopt sort of common things out of the box. So this results in implementations continuing to look the same, even across teams that are doing their own development and their own execution, right? They're all autonomous. And it allows individual teams to free up some time to focus on the things that they want to focus on, right? What makes them unique. And so these multiplier patterns are the patterns where we want to spend most of our time. We still want to contrast a little bit to the established patterns. And if we think about that monolithic world, extensions or new features are typically built within an existing code base. So how does that work? Well, somebody kind of checks out their repo and they figure out where they need to make a change, and more or less, a lot of the changes are copying and pasting existing code and making your change. And this naturally is reinforcing existing code patterns, right? You're at least opening the repo and you're seeing kind of how things are done. And by code patterns, I mean things like your singleton patterns or decorators and your more like established common patterns, right, of writing code. So these types of patterns are low risk, but they're also not particularly innovative, right? So they're the bottom of our graph. And as an architect, you probably want to reinforce these patterns, but you're not going to spend most of your time on established patterns, right? Because they're established. So flipping to the other side, though, we also want to consider the most innovative, but also some of the higher risk approaches. And these are called our cutting edge patterns. And these are sort of our latest and greatest trends in the industry, right? And this is often a double-edged sword, because on the plus side, these cutting edge patterns, these are the things that actually can accelerate our innovation, right? So we want to sprinkle them in, but like most things in tech, there's a trade-off here, right? So sometimes always there's negatives. There's there's never a free trade-off, but sometimes those negatives are sometimes a bit underestimated, especially for newer technology. So again, we want to sprinkle some effort here, and basically we're throwing some darts against the wall here, but we want to identify those that stick, right? And those that stick, those are our multiplier patterns. Those are the ones that are hitting that sweet spot of risk reward. All right. So while we're often thinking about architecture patterns, we're actually simultaneously driving those patterns through and changes through projects, right? We're executing projects. And so one of the most important parts of planning projects is to think about incremental architecture. This is another part of pattern number 3. So at Atlassian, we have a principle to try to avoid these big bang projects. They take a long time. They just don't realize a lot of value until far into the future, and they carry a lot of risk along the way. So what's the risk that we're talking about, right? Like what's the problem here? Well, it really means that the longer you're working on something, the more likely it is that something changes around you. So the people that are involved with the project may change, or customer demand may change, or the technology that we're using changes, there's a reorg or architecture changes, all these kind of things change, right? So instead of delivering these big bang projects, we want to think about how we can break them down into smaller incremental deliverables. And each of these incremental deliverables, we want to design them in such a way as architects so that they independently have value, right? And together, they ladder towards our final outcomes. You can see that on the graph here. So another benefit here is this provides us flexibility to leverage what we learn and adjust our goals along the way. So this is maybe a slightly different path than what we thought, but it'll still get us to a possible end state. And that blue background cone that you see, that's the thing that's indicating acceptable outcomes, right? So we sort of know where we want to go at the end, but we don't know exactly how we want to get there or exactly what the end state looks like, but we have a pretty good idea, right? This is our painted pictures. And by delivering incrementally, we may find it a little bit more optimal to find a slightly different path or a slightly different outcome as we go than we originally thought. And like you saw that movement, it lets us readjust our expectations as we go. So sometimes even what we originally thought may look a little different when we start to deliver those milestones incrementally. So we want to talk tangible here. Let's walk through an example. So an example of a multiplier pattern internally has been that sometimes has been like a couple of years ago, we started on a project that used Open Policy Agent. This project was run by an internal security team, and it used this OPA, Open Policy Agent, and also the Regal language. And the goal was to improve the way we did staff authorization into production systems. So at the time, it was fairly popular in the industry, but it was really new for us, right? We hadn't done anything with it on a larger scale. So for us, it was still in that cutting edge pattern category. So we started small, right? We built rules for a single API on which staff members and when they're authorized to actually call a production API, and we did that within a single service. And then slowly we expanded it, right? The natural progression, we expanded to more APIs, and naturally we then expanded to more services. And at some point along here, we hit that sweet spot, right? We saw enough success and we saw enough potential to help lots of our internal initiatives that we basically said, this is now a multiplier pattern. And as an example for the process side, within Atlassian, architects have actually organized an internal framework. It's called Project Stitch. And what Stitch is a way to standardize these multiplier patterns across all of our engineering teams. And this was a great example because production API access into all services was relevant for everybody, right? So we did this. And then naturally we expanded it, right? We started to build upward again. We enhanced the feature set more. We expanded it to include infrastructure access and common logging. And then we continued to move it horizontally. More services were included and they adopted it. And you kind of get this organic growth at some point, and it'll continue to get improved and expanded, right? But the key takeaway here, as you see on the screen, is that at each step of the way, we had to accept that what we were pushing across teams was not the complete end-all and be-all solution, right? We had to push through those objections, working with what we had, delivering incrementally. And as we went, we built and we learned and we iterate along the way. And what we want today definitely looks different than what we want when we started We still have adoption and we still have feature coverage. All right, perfect. So we've talked about sharing architecture patterns. But architects are still engineers, right? And so it seems a little weird that we haven't talked at all about actually sharing code, right? Code reuse 101. So what are we talking here? Well, a platform, right? What's smart platformization? A platform is actually just the microservice form of a library. So platform services, we invest in them so that we can offer reuse of core capabilities across lots of services. So at Atlassian, we've been investing heavily into platform for many years now. And we found that it's important to think through the why and also the when to make a platform. But we first need to actually break down the term platform. So let's do that. There's actually 3 types of platform that we're talking about. First, there's this primitives platform that we've coined. This is your core backend infrastructure components, right? These are things like your build and deploy pipelines, right? CI/CD, or things touching infrastructure like AWS accounts or configuration thereof, things like this. Next, we have a product platform. And this is the kind of thing that's customer facing, right? It's a platform to build your products on. So it's intended to create a similar look and a similar feel across all of your experiences or capabilities or products, and to create those sort of shared experiences across everything that you're offering and putting in front of customers. Finally, we also have this platform product. And this is the kind of thing that you find on Google. And this is allowing external developers to build on top of your platform. These are like add-ons for Jira or Confluence or something like that in the Atlassian world. So what's important, though, is that we want to talk about why and when we want to build them. Let's do the why first, the first column. So we want to build primitives to improve our engineering excellence and to increase our efficiency. When we invest in these kind of infrastructure things, it's helpful to bring together experts from across the company and have them form a team, right? Even if it's distributed, it allows them to specialize on the things that they do best, right? And optimize sort of this primitives platform. And this was actually one of our first platform teams at Atlassian. It's called Cloud Infrastructure, right? And Cloud Infrastructure has sub-teams. They focus on our network, on our access controls, build and deploys, AWS, configuration, and all this kind of stuff, right? All right. One layer up, we were talking about this product platform. And so we want to have a product platform to make your capabilities and experiences cohesive. We're really doing this to create that network effect, right? This is that thing that makes your products feel really polished. And finally, on top, we're talking about a platform product. And with anything, apps, ecosystems, add-ons, this is a market share play, right? But it's important to note that we found that it's really hard to build that platform product without solid maturity in those other areas, right? So that's a good takeaway. ROI you see, but let's skip over that for now. I think that's fairly straightforward. Let's talk about the when. This is a really important thing. So for something in platform, you have a couple choices, right? You can start to build it when nobody's using it. That first dot there, you have 0 customers. Well, why would you do this, right? You do it because you think it's going to be needed in the future, even though nobody is necessarily using it right now. Or you wait till somebody wants to use it, right? Your first customer, your first early adopter, and basically you build it together, right? And you make it happen. Or you wait till you have 2 or you have more than 2 customers. And this is your deferred platform. Obstacle here is you basically have to go back in the teams that have already built something. They have to refactor or basically migrate onto your solution. So overall, the left is a bit more proactive, the right is a bit more reactive. And what we found at Atlassian is that actually the sweet spot for product platform is actually somewhere before the first customer, right? Right in between that 0 and the 1. And this is generally because this is something that's customer facing. So generally there's an urgency that comes along with it. Given a microservices architecture, teams are actually encouraged to go build it themselves, right? So if yours is not ready, they'll just basically go ahead and like build it, right? And for somebody who wants to build a platform, right, this kind of sucks. Last thing is it's also customer facing. So migration after the fact is kind of painful, right? We need to be really careful because it's customer facing. We need to carefully plan it. So what's interesting to note is actually we find that the opposite holds true for the primitives platform. And you probably want to wait to invest into your primitives platform purely because it's on the back end, right? And mainly because teams are actually incentivized to move on to a platform for primitives because it actually reduces their KTLO, right? So rather than them having to maintain the thing that they've already built by onboarding onto your platform solution, they're ahead, right? So they're naturally incentivized to do it. So those are our key takeaways for smart platformization. And let's do a quick recap. So we went over 4 patterns here. The first was architecture guilds. This is bringing together a group of trusted architects, giving them a clear mission and letting them run with it. Next, we talked about trade agreements, which was facilitating teams to be able to work together, specializing in what they want to do best, right? They're microservices, but still leaning in to help each other when they can. The third one was we talked about those multiplier patterns, which requires architects to identify those sweet spot patterns and go and drive adoption across lots of services once they're identified. And lastly, we talked about smart platformization. And the key here is to recognize when and why you want to build certain types of platforms. All right, I'm going to hand it back over to Sidney to walk us through some last takeaways.
Alrighty, yes, thanks, Jeff. Last takeaway. So yeah, the three key points to take away. So firstly, beware that false autonomy that microservices bring, right? The dependencies that we had in the monolith world, they still exist, they're just in a different form, right? And beware of those silos that get built up now because services are owned by teams. Secondly, it's really important to remember humans and trust equals to effective software, effectively built software, right? So we really need to work on building or establish that trust to improve productivity, right? So think those win-win for teams and the company involved. And finally, as technologists, it's really easy to get sort of caught up in technology and code and so forth. But to rebuild that trust, we actually need to invest a lot more in the people and the process, especially because we can't get away with making a change in a monolithic code base and have it spread out. Teams are independent, they have different code bases, so we need to work on people and process to make it happen. All right, so that brings us to the end. Feel free to reach out to us about this topic or anything else you listen to the screen. Yeah, thank you very much for listening. Let's take some Q&A.
Fantastic. Thank you so much. We do have some questions for you, so we'll try and smash through them as quick as we can before our next talk, or the end of our day, I should say. So first, architects influence change by designing, mediating, and negotiating. What is the balance of importance between technical skills and people skills for an architect?
It's a great question.
I think that was from the part that Jeff.
Do you want to take this, Jeff, or do you want me to take this? I think we're both equally good. You go first.
We describe this as a trio, right? That technology, people, process. It's hard to have any one or two of them without the third. I think naturally, as architects, you probably have a stronger background from the technical point of view, but you're not going to get super far by just relying on that, right? So you have to lean in and kind of understand how to motivate people and drive people towards a common goal, right? So those people skills are still important. Anything to add, Sidney?
I want to add this one thing around one part around the types of the roles of engineers. If you look at the deep engineers, probably more technical, but still they need people skills because they need to work with their team, right? They need to be able to engage and so forth. Whereas you're more on the broader architects, again, you're probably more working across different teams, different skill sets. You're working with product managers and business people and so forth a lot more. So probably more focused on the people skill, but it is still very important to have technical chops because otherwise the other engineers won't trust you. So it does vary, but definitely both are important.
Yeah.
Okay, thanks. How do you tell when your multiplier pattern becomes an established pattern, and what are the signs to look out for?
That's a good question. I'm not sure we've had so many examples of this actually internally. A lot of our multiplier patterns have shown a lot of success, and I think the established. I guess what's different in the microservices world is that a lot of established patterns don't exist because microservices are relatively new, and the integration patterns between those services is relatively new as a result, right? So like even like a an industry standard is like using Kafka to communicate across services, right? It's still sort of outstanding, not established patterns as to how you drive consistency off of a Kafka offering or something like this, right, across microservices. So I'm not sure we've quite gotten to this point quite yet, but I'd imagine when we do, we'll see that those are the types of patterns that are just like tested, right? Like everybody just accepts them as the go-to, and there's not a lot of alternatives that sort of float up as options. And we see this in the code world, right? A lot of this we just haven't kind of gotten to that maturity in the microservices world.
Yeah, can I add one item on that? I think the return on investment is really important there. I suspect that's where we're going to hit that point. When we get to a point where changes or making a pattern or working on a pattern has a lower ROI, then that's probably when it becomes more established. Like you said, like there's no point working on test-driven development as a pattern because everyone's doing it. There's nothing new to add there, right? Whereas there's a lot more opportunity. But yeah, like you said, microservices are still relatively new, so there's a lot of opportunity to invest.
Everyone's doing test-driven development.
Yes. Now we've forgotten where it came from, right? So it's so established.
Okay, so next question. Are some of these patterns / practices based on Wardley mapping?
That's a great observation. Wardley map is definitely been one of my recent reading materials. It has definitely, we've found a lot of, yes, I would say there's a lot of implicit and explicit use of Wardley in our work and our patterns. I think it's, yeah, if you haven't read Simon Wardley's material, definitely totally worth reading. It is extremely valuable, extremely interesting, and it's well written as well. So yes, shorter stories, yes.
All right. I think, oh no, wait, another question. Good, we got time. At what company scale do we hit the problems that you've described in this talk?
Whoa.
That's a good question. I'll take a stab. I think some of the different problems come about based on different sizes of technology, right? So like we talked about some of the platformization, and you're going to get that even in a small company, and you're going to have to make the choices when you want to invest in certain types of platform components. But as you scale, especially across geo and teams, and your teams become departments, and your departments become organizations internally, you'll continue to run up against those people obstacles and process obstacles. And as architects, we found this is really key to kind of identifying it. I'd imagine that the size of the company is less of the driving factor and more on the sort of the organizational structure, right? Obviously, you'll only have that of a certain size company, but yeah, I'm sure it's in the hundreds if I had to guess. What do you think, Sidney?
Yeah, I'll add. It's probably so. Yeah, you definitely don't want to put this kind of heavyweight process on a very small startup of 10 people, right? But I think it also depends on. Also, I would say with the remote working situation we have now, I think there's certain patterns we've seen that actually apply when the company's actually quite small. You know, because you don't have the opportunity to get everyone in a room and chat, right? You need to have a little bit more structure around, okay, how do we make decisions cross company where, you know, you have people in the US and Europe and so forth. So yeah, so I know some of the patterns we've talked about today, like the guilds, you know, like Trello, for example, I think have a similar style, have been using it for a little bit, even when they were a lot smaller, because the distributed nature of the organization at the time, right? There's some value there. So, but yeah, it definitely does vary. I think when you start seeing the communication boundaries sort of silos being created because of technical or geographical other reasons, that's probably when we start needing to think about these patterns we've talked about today.
That's a good tip to look out for. All right, thank you so much for your great talk and your insights today. Much appreciated.